Assalamu alaikum wa rahmatullah. I welcome you all to the sixth video. In this video, we will explain application of Newton's and conservation of momentum laws. Sir Isaac Newton had three laws that we still study today. Three laws of motion. Law 1, which tells us about inertia. Law 2, which helps us to calculate force. And law 3, which tells us that action and reaction are equal and opposite. Now, these three laws, and in addition to the three laws, you also have conservation of momentum law that says when in a system of colliding particles, provided there is no external force acting on the system, total momentum before collision equals total momentum after collision. Now, they have real applications in nature and we benefit from these applications. The first one they mention is the recoil of a gun. The recoil of a gun can be explained using Newton's law and also momentum law. Here is what is happening. They explain it. They say when a bullet is fired from a gun, the gun jerks backward or recoils. Whenever a gun is fired, the bullet comes out of the gun in the forward direction. Now the gun will move in the backward direction. It always happens whenever it is fired. They say before the gun is fired, the initial momentum of the gun bullet system is zero, meaning the gun and the bullet were at rest. And because they were at rest, each one of them has a zero velocity. Because momentum is mass times velocity and they have zero velocity, so they consequently have zero momentum. The gun has zero momentum, the bullet has zero momentum before firing. Now here is the next thing. When the gun is fired, the bullet moves forward with a certain velocity. You see that? The bullet is now having a velocity. Okay? It has a forward momentum equal to m1 v1, meaning the bullet m1 is the mass of the bullet and v1 is now the velocity of the gun after it was fired. Okay, so it means that the momentum of the gun after firing will be m1 v1, where m1 is the mass of bullet and its velocity is v1. Now the momentum of the gun itself, okay, will have a momentum and it is given by m2 v2, meaning m2 mass of the gun and v2 is now the velocity of the gun. But initially they had zero momentum because they were all at rest. Since the momentum must be conserved, remember we say total momentum before collision equals total momentum after collision. So if momentum is conserved, it means this is the total momentum after collision is equal to total momentum before collision will be zero, of course. Hence, m1 v1 equals negative m2 v, meaning if you take this one to the other side, it will you will say this is equal to negative m2 v2. The negative sign shows that the momentum of the gun is directed oppositely to that of the bullet. Remember, momentum is a vector. Since they move in opposite direction, they will have vector with opposite sign, one positive, one negative. The momentum of the bullet, if you take it as positive, then the momentum of the gun is negative, but their sizes are the same. If this one is 50, this one is also 50. The only interpretation to the negative sign is that they are oppositely directed. If this one is directed to the left, the other one to the right. If this one is upward, the other one is downward. If this one is in plus x direction, the other one should be in negative x direction, and on and on, oppositely directed. Therefore, the gun jerks backwards or recoils because the mass of the gun is much. Now they are going to explain this. That because the mass of the gun is much larger than that of the bullet, we know that the bullet has a very small mass. The mass of the gun is much. This means much greater than m1. the velocity and kinetic energy of the gun are much the velocity and kinetic energy of the gun are much smaller than those of the bullet. This means um, the gun will move backward, but with lesser velocity because it is heavy, okay, with lesser velocity, and the bullet will have great velocity because it is light. It will have great velocity, and because of that, the gun also will have lesser kinetic energy, because half mv squared that you have, the v is very small, okay. So okay, I'm back. The gun will have lesser kinetic energy, lesser velocity, because the velocity of the gun is less than the velocity of the bullet. We can also and okay, let me explain this. In the military, uh, the soldiers during training, they are advised, always advised, not to hold the gun against their shoulders, not to hold the gun against their shoulder, because if you hold a rifle against your shoulder, after firing, it will recoil back and hit you on the shoulder, okay. And for that, they are always advised not to do that. Okay, let me show you something here before we continue. Here, okay, look at how this man held the rifle. It's not directly against his chest, okay, because after firing the rifle, you expect the rifle to recoil backward, to move backward. If the bullet is fired here, then the rifle will move backward. You see that? So if you hold it against your chest, it's gonna hit you on the chest. Okay, this is part of military training to make sure that the laws of physics are always obeyed. Okay, let's go back. Okay, we we can also consider the system as a case of operation of Newton's third law, of course, because the bullet will have action force moving forward with it, and the gun will have a reaction force moving backward. And this is why they say Newton's applications of Newton's law and also conservation of momentum. The propulsive force acting on the bullet must be equal to the opposite must be equal and opposite to the recoil force, which is the reaction acting on the gun. I think they have a diagram for this. Let me see. They should have a diagram. There is a diagram for this, I think. Here is the diagram. You have the bullet and the gun at rest, but after firing, okay, the bullet now moves with the action force, and the gun recoils backward with the reaction force according to Newton's third law of motion.